Welcome to Programming in Modern C++. We are going to discuss the second tutorial. So, in the first one, we have talked about what is the relationship between source and header files and what are the differences. And particularly, we took a step by step look into how does C preprocessor CPP can be harnessed to manage code during build. So, this tutorial is also continuing on the project building process. We are going to discuss about the build pipeline, specifically with reference to GCC, which is the compiler we have been using, how to work with C or C++ dialects during the build, and understanding little bit more on the C standard libraries. So, this is the outline. So, let us start with the build pipeline. So, let us take a look. This is where I have my source files, the translation units we have talked about. In tutorial 1, we have discussed how CPP changes that file, does the replaces the include, the hash define, does conditional compilation and so on and so forth. After that, it generates the corresponding C or C++ source files, which does not include any preprocessor directives. It is a pure C or C++ program. There is all library headers, everything is included in that one single file that is typically has an extension .i. Then the compiler will actually do the compilation process, will generate the assembly corresponding to this. That is a huge translation process. We do not need to understand how it is done, but it is translated into the assembly of the processor on which you are targeting, and those files generated corresponding to every translation unit is typically designated by .s. Then the assembler ticks in automatically, we do not have to do anything for that, and that will convert the assembly language program into a binary code, which is known as the object file. It is a binary code, it is no more assembly, is still has a textual representation. You can read the assembly, you can write assembly, but this binary code is just bit patterns, right. So, it is not humanly readable. These are object files. So, these are called shown by the extension .o. Then the linker kicks in. What does the linker do is, you have seen that we have, say, in a stdio.h, we have printf function. So, stdio.h has just the header of that function, but the actual body of that function is in some other translation unit, which is already compiled and available as .o. Now, from the main, if I am giving a call to printf, then naturally I need the body of that function in terms of the object file, the printf function, to be included in my executable. So, linker is that part of the compiler which actually finds out for every translation unit what are the symbols, say functions and global variables, which it uses, but does not define within it, and those which it defines and makes available for others. So, it relates them across the different translation units, so that finally, I can put all the object codes of all translation units into one single binary file, which is the executable file. Right. So, while doing this, the library codes that are already available in the system, they are already compiled in the object file, are also looked for, they are also linked. There are a variety of libraries we will see. Here is the particular one being shown is a .aso library called the shared object library. There are other kinds as well. So, when we just do GCC or G++, this whole thing happens taking this collection of all translation units that are involved in the project and finally generating an executable. Right. So, this goes by stages. So, what we will do is we will see what happens in every stage, and we will see options as to if I want to look at the output of any stage in the build pipeline to understand better then what are the options to do that. So, having said that, let me now move on to the actual pipeline. So, you have a C preprocessor which takes source and header files, then the compiler and generates a .i file. Compiler comes in, compiles and generates the assembly language .s file. Assembler translates the .s into .o object file. Linker links all .o files with the existing libraries. These are called static libraries .o or shared library or dynamically linked library. We will have a separate tutorial on this to discuss what does that mean, or library archive, we will also talk about that, and finally produces a single executable file a.out. Right. Now, these extensions that I have mentioned is for a GCC running on Linux on a different OS on a different system. These extensions could be different. So, you will have to check the documentation of the compiler to see exactly what are there. I mentioned this earlier also, but here I would reiterate that you must have the GCC installed in your local system. If you are using Windows, then use MinGW. I have given the links and all that earlier. If you are using Linux, usually it is included in the Linux distribution, check that manual. So, with this you will be able to, every example that we are discussing in terms of the modules, you should be able to just make them into source and header files and compile them using the GCC G++ to get going. Now, if you want to do a quick check of a small code and so on, it is not good for big projects, but if you want to do a quick check, then you can use online versions of various compiler, online available compiler like GCC GNU compiler is what I will again highly recommend, which has a variety of different language dialects to choose from, and you can use tags like in here. We will talk more to select which particular version or which particular dialect you want to compile with. Then you have from similar online compilers from CodeBlock, Programmese, One Compiler and so on. And while you are using the compiler, you must know the version or the dialect of the language you are using. So, what is GCC? If you have a question, then GCC is a GNU compiler collection. So, it is mainly referred to for C and C++, but there is a huge range of languages for which the GCC compilers exist, starting from Objective-C, C++, Fortran, Ada, Go, new D language and so on and so forth. Now, there are different options which will allow the GCC compiler to be controlled at different stages, and that is what we will now take a look at. So, you would have noticed that I am talking about compiling with GCC or compiling with G++. So, there are two compilation commands in the GNU compiler collection with reference to C++, C++ bunch. So, you use GCC to compile, typically compile C program, and use G++ to compile C++ program. and the difference is what actually they are the same, compiler, but it's a different set of rules that you are applying. So, this second point is most important, that is G++ can compile any .c, that is C source, or .cpp, that is C++ source, but whether it is a C source or a C++ source, if you use G++, it will always treat it as by the C++ rules only, right. So, even the C program will be compiled with the C++ compiler. So, if there are compatibility issues, you will have problems. Whereas GCC makes a selective choice. GCC decides which rules to apply based on the extension of the program. If it is a .c extension, then it will be treated as C by C rules, it will be treated and compiled as a C program. If it has .cpp extension, that will be compiled as C++ program respectively. So, you can make your choice. Now, when you compile with G++, you are doing a C++ compilation. So, it does automatically link all your necessary libraries, that standard libraries I should say. Whereas, when you do for GCC and you are specifically want to build a C program, then as a final executable, then you will have to link the standard library of C++ if you need to include that, right. So, these are some of the things. Let's go to the command chain and you will see all of that happening. So, this is just by stages of the pipeline. So, initially what you do to keep things simple, just put all your source and header files into the current directory, right. You can distribute, have organization, we will talk about all those later, but just to see the compilation process, put all your files in the current directory, and if you check the directory with ls or dir depending on the system you are on, then you will see something like this. The output that I am showing here are from my Windows 10 machine using the command prompt. So, here I have 3 files, one is a factorial header fact_h, one is a factorial source which has the function implementation fact.c, and then there is a main program which is using the factorial function including fact.h. So, you can see that there are 3 files therein. Now, we can compile using, so you have to compile each and every translation unit, each and every source file. So, you will have to compile this, you will have to compile this. So, when I compile, I am using an option -c. Typically, when you say minus on the command line of the GCC or G++, it means an option which does behave in a certain way. So, if you put -c, what it does, it will generate the object file in this manner. So, after you have compiled both with -c, you can again list the directory. You will have the source and headers also. I am just for brevity, I have not shown them, but these 2 files get added, that the object files have been created, right. Now, you can use those object files fact.o and main.o to actually, so you have come up to the object file directly. So, all that you need to do is to take all translation units and try to link them together. The reason you need this -c here is, in this case, none of these programs or none of these source files are independently complete to be converted into the final binary executable. So, you want to tell the compiler that you compile up to the object level, but do not try to link. If you just do GCC main.c, it will the compiler will generate main.o and then start shouting that I cannot find where the fact is, right. Similarly, if you just compile fact.c, it will complain that there is no main function in this source. Okay, so, you need to stop it at the object level and then take all of these objects to link together, and you do not have to particularly call that linker like LD and so on. You do GCC again, and the fact that you have given .o file, the GCC knows that this is the object file which needs to be linked. And if you do not give this remaining part, then it will generate in a.out or a.exe depending on the system you are on. But if you want to give a specific name to the binary file executable that you are creating, you can do that by using the -o option. So, I am calling it fact. Right? So, once I have done that, my executable is ready and I can see that added to my directory folder, fact.exe, because I am on Windows. And then I execute fact, and this is, so this is a basic step to build. Now, I can also combine these 2 and 3 together by giving multiple source files, translation units to the command line at one go. So, GCC fact.c men.c will tell GCC to compile and so compile, generate object file and then try to link them all together, generate a binary. So, this can be done in a simpler way like this in one step also. Now, if you want to see what is happening at the intermediate stages, then you can use different options. For example, you can tell GCC just do the compilation and stop at the assembly, do not kick in the assembler, use a -s option. We were here. So, use the -s option. If you use -s option, then the compilation does not go up to the object file. It stops after the translation only at the assembly level. So, with these different translation units that you have given, you will see that you have 2 .s files. You can use a text editor to open it, and you will see that the assembly language program corresponding to your C program has been created in that. Of course, if you to understand that, you will have to know the assembly language for your system, for your processor. If you want to stop even earlier, that is after pre-processing, you just want to see that what does CPP has done. It is a great learning that after replacing a hash include, hash if def, hash define and all that, what is that you get, then you can use the -e option. Now, this will generate the output into your STD out, that is your standard out, right, so on the console itself. So, if you want to and it usually is huge. So, if you want to keep it and see separately later, then you can redirect. This is a redirection greater than redirect to a different file, and I am specifically called it by an extension .c, because after the replacement it is a purely C program. So, it will also strip all comments, it will textually replace macros and all unnecessary codes which you had done hash if 0 or something are all removed. It is a fun to see that. Please try it out. I cannot show you on slides because it is just too huge to show. Now, finally, if you want to know what is the version of your compiler, not the language dialects will come separately, but what is the version of the compiler? Well, compiler is regularly getting released. What is the version that you are using? Then you can always do -- there are 2 minus required, -- version, and it will tell you the version, where is it coming from and so on and so forth. Right. So, these are now often we would like to do a debugging of the code, that is not just run it, but start running it, stop in the middle of execution, check what is the value of the variable, maybe set a specific value to a variable, give a breakpoint and so on. I will talk separately on debugging in one of the tutorials, because that is a very important process. And GCC has a corresponding debugger called GDB, which is GCC debugger, Now, if you want your code to be debugged, then your normal compilation will not do. So, you will need to give a -g option. So, everything else remains same, you give a -g option. By that, the final binary that gets generated is empowered with annotations for the debugging, and also it does not do any optimization of your code, so that you can really go and keep on during the execution, you can keep on checking. Right? So, this is something which you will very frequently need. I have a recommendation for you that besides the errors, if the compiler has an error, naturally after that stage you cannot proceed, you will have to fix that error. But compiler also gives a number of say warnings, right, which is so he said this is the warning and so on. For example, if we comment out, you will have to refer to the previous tutorial to see the code. For example, if we comment out this and try to build, then we will get f is used uninitialized in this function, right. That is, I am trying to print f and I have not computed f. So, f has not got any value yet. So, it is not a language wise, it is not an error, but programming wise certainly the compiler is wondering why do you want to print a value that you have not even initialized. Right? So, the compiler does not say it is an error, because it's a correct program. Otherwise, program logic is your programmer's prerogative, but the compiler wants to warn you. Now, it is good to build with -w all. It looks like wall, it is actually not. That -w is to say that what kind of warning you want the compiler to give, or what kind of warning you do not want the compiler to give. All says that you give me all kinds of warnings, right. So, -w all will give you all kinds of warnings, and it is good to remove all warning. With the warning also you can proceed, but it is best to remove all warnings, because with the warnings, if the warning is given, there is something that is probably not correct. So, for example, here you could proceed, but you will certainly have a garbage value, and you will have to come back and check and debug. But if you take care of this warning, at the compilation time itself, your logical error of having omitted the right value to f will get detected and fixed. You can also tell the compiler that I do not ever want to work with warning, by telling that, giving an option that -w error. So, what then the compiler will do? It will treat every warning as an error, and it will not allow you to proceed unless you fix that. Right. So, these are the additional things you can do. And finally, if you are really motivated to trace what the compiler is doing along this build pipeline from one to the other, then you can tell the compiler with an option -v. V here stands for verbose, that the compiler becomes talkative now. Usually compilers only give errors or warning messages. Now, it will start giving all kinds of what it is doing. So, it's hundreds and hundreds of lines. So, I have just shown you few initial ones. It says what is that, what is the folder it is taking from, what is the target that it will generate, what is the kind of thread it will use, what is the version of the compiler, but the very right truncated, there are hundreds and hundreds of lines of dump that comes in. You can put -v and see for yourself. It is good fun, but on a regular basis you will not be doing this, of course. So, just to summarize, these are the different, you can just keep this chart handy. These are, you will get them in GCC manual also, but I have excerpted only the common part, which you in GCC manual this runs into maybe 10 pages. I just accepted that part which you will need 95 or maybe 99% of the time. So, these are the options, the behavior under that option, what is the input extension and what is the output extension. So, if you have this, maybe you can paste it in front of on the wall where you work, so that you can at any point of time just look up and take that appropriate action. In terms of the source file, I have already talked about, these are the three possible extension, .s for source, .h for header and .s for if you have generated assembly. Now, the corresponding file type, as you will see that I had mentioned this in tutorial 1 2, that there are variety of standards people have worked with, variety of extensions. So, in a system, in an existing system, when you see in a say in GitHub or somewhere, or maybe in your company, you will see a whole lot of different extensions being used. So, learn what extensions mean what, but the most common and standard extensions are which are highlighted in red. These, and when you are writing it, try to always follow this convention, and that is what we are going to do. Okay. So, this was the basic stuff that I wanted to discuss with you in this tutorial. I will just quickly run through few related issues here. One is I said in module 1 discussion that there are different dialects as standards have happened. So, these are the different dialects, and we will keep on switching between typically between C90 and C11. This is not C++, this is C11, right. So, the standard that you have, this is so when you use your C compiler, say you are using GCC with .c file extension, you might want to know, or you might want to decide even dictate that what kind of, which version should you use, because there are different support that are changing from one version to the other. This is a small piece of code with some magic numbers which are defined in the CPP's macro for every standard, which you can use to detect which particular version you are using. So, if you want to use say C99 version, then you can write it as -std. -std is a compiler option which say what standard, and C99 is the code for the C99 standard. So, if you build the above code with std -std equal to C99 and run, you will get this output, C99 output. If you just build this, of course, it may be different in your system, because it depends on the compiler version you have actually installed. But if you do min-gw now 6 version plus, then the default is C11. So, that is the reason I said that C11 is what. So, the default is C11. So, you will get this. If you also, you can set that I want to build with C11. So, say to ensure that, well, I do not care about the default. So, -std equal to C11 will build the code in C11. So, GCC has whole lot of different options for standards and so on. I have just taken the few which are important. Similarly, for C++, you have different dialects as from the first standard at C++ 98, which we say, which is what we are doing now, and over weeks 1 to about 8 or 9, we will talk about this standard only before we jump into the C++ 11. Now, so, and when we talk about C++ 11, we will actually talk also about some 14, 17 features, maybe some 20 C++ 20 features also, but our primary choice will be C++ 98 and C++ 11. C++ 98 for the first 9 weeks. Now, also note that there is a C++ 0th version, and you may have noticed that I keep on using these terms interchangeably. I say C++ 03, I say C++ 98. Actually, C++ 03 is the same standard as C++ 98, except that C++ 98 had some bugs which have been fixed in the C++ 03 dialect. Right? So, like in C, here is an equivalent for C++. You can check the version, you can set the version, and the details you can really work out. Obviously, there are standard libraries, as you all know, and which is along with the language, the standard library extends the overall capability of programming. It makes it easier. So, it is, as you learn the language, it is very, very important to learn the standard library, because that will make your programming really easier, because lot of things like lot of C programmers are writing sort routine without probably knowing that qsort is available in the library, right. So, that kind of I discussed that. So, now the question is how much is in the library in the language and how much is in the library. It depends on the it's a language's choice, right. For example, in C there is no string type, it is a string library which provides that. C++ has made string also in the library, but as a more complete type. A even stronger example is dynamic memory management. In C, it is a part of standard library, right. You have all these malloc, free and so on. In C++, you have language operators, new, delete. You have you must have heard me on the specific modules on that. So, it is a language, and standard library design is a very careful thing, which has to be small enough so that people can learn and remember. At the same time, it must be reasonably powerful so that a large collection of software can benefit from that, right. So, these are some of the standard. I will not go through these are, you can just refer to the slide. These are some of the very common and useful, and you must have seen that most of the examples are using this: stdio, stdlib, string, math. These are the 4 that you more often use. If when you handle error, you will also use error. So, some snippets of what is inside the header. Similarly, C++ libraries, there are many again, and I will slowly introduce them as we go through the modules, but IOStream, string memory, C math from C, C stdlib or C string, vector, these are some of the important ones. I will not discuss this in the tutorial, because we have already discussed this in the module in terms of what is the difference between the std namespace and other, and what are the header conventions. These we have already discussed in the module. So, just remember to follow them. Right. So, I hope you have got a good sense of how to do this build process. I will also make a small video later on to actually do these steps while I use my GCC, so that even after this discussion, if you have difficulties, you can just follow those steps in the video. I will also provide that at a later point of time. Thank you very much for your attention, and see you in the next tutorial on the SEM project building process. Thank you.